Hello, everybody. Welcome back. We're going to continue moving forward. Week 3, number 1, insert interval. So it looks like we're going to start doing a lot of medium problems. And eventually, let's see when it starts getting hard. Week 8, we're going to start doing hard problems. All right, let's get started. Insert interval. That is number 57. You're given an array of non-overlapping intervals where interval I has a start and an end. So it could be a tuple, could be a list of two items. Represent the start and the end of the ith interval, and intervals are sorted in ascending order by start. So very key important things that they are already sorted, right? So if there's a number line here, these intervals are already sorted wherever they are. Another key point is that they're not overlapping, right? So if they're overlapping, then you can imagine there's maybe some issues that we have to deal with by maybe merging all of these overlapping intervals and doing some logic with that, right? But thankfully they're not. They're sorted and they're non-overlapping. So you can imagine these intervals are like this. There's no need to sort them, and there's no need to get rid of some of them by merging them. Okay. Insert new interval into intervals such that intervals is still sorted in ascending order by start, and interval still does not have any overlapping intervals. Okay, so here's where it gets interesting, right? Go ahead and I'll make this one red. Now we're going to insert a new interval. It's going to come in as interval, and it could be anywhere, right? It could be here, could be here, could be here, could be here. It could even, be earlier than all the intervals. It could even be later than all the intervals. Be outside the bounds, right? So something to think about. Return intervals after the insertion. Okay, so we have to basically make sure that this gets merged correctly and then return the results array. Note that you do not need to modify intervals in place. You can make a new array and return it. So that's an interesting note. I say that's kind of an unexpected note, but it's an interesting note for them to tell us that we have an intervals array, right? Let's say it's an array. It has some items in there. And what we need to do is not update it in place. Maybe that's going to save us memory or time, but we can go ahead and create essentially a new one. Spelling results wrong here. We can create a new results array, and that can start empty, and maybe we can start populating things into here, right? Populate that, populate this, and these become what we return. Okay, so let's look at example 1. The input is intervals, so we have, let's say 1, 3, 6, 9, and the interval is 2, 5, right? So let's say this is the, let's call this a number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess we can start it at, go ahead and start that at 0. Right, this is the number line that we have. And we have a couple intervals already. I'm going to make this blue. Interval 1, 3. So 1, 3 exists as an interval. 6, 9 also exists as an interval. And I'm going to put this in red. We want to have new interval 2, 5. So 2 is going to be here, and 5 is going to be here, right? So just from looking at it, we can see that there's some overlap, right? There's this overlap right here at the 2, and then this here at the 5 does not overlap with the second interval. It only overlaps with the first. And the output that they want, I'll go ahead and make this yellow, is 1, 5 as an interval. So 1, 5 as an interval, which is, the end of this and the end of this, basically. So if it overlaps, we want these kind of merged together. right? And then 6 and 9 as a different interval that is untouched here, right? So that's interesting. Let's think about the cases that we're going to have to deal with, right? Now, this red interval here, it could have been here in this 2, 5, overlapping with this. It could have been here as well. Forgot to take the little dots with it. Let's get rid of these dots. Could have been here as well, right? If it was here, then we need to merge it with this interval. It could have been, so let's think about the cases. I'll go ahead and take these 2 blue ones. And there's a lot of mess that comes with that, but that's fine. So it could have been completely before, right? So this is a case before completely. It could have been completely after, right? Case completely after. And let's just kind of mentally iterate through the different cases that are possible. I mean, this is a case as well where it like completely engulfs everything, right? It's super possible as well. Put this here. Put this there. So this case will be called engulf. Maybe I put a line through here so we know that these are separated. What else could there be? Well, you know, it could just be a regular needing to merge, right? So if you need to merge, it could start from the outside and then go into the inside, right? It could start from the inside, right, and go to the end, right? It could start from the inside, go past the end, right? It could be completely larger than this one, right? It could be so much larger it engulfs 2 of them, right? And those are the cases if it overlaps, I guess. This would be a case overlapping. So how would we think about the code here? So let's just walk through some of them, right? So I'm going to make a star for a pointer, and I need to at least iterate through the existing intervals, right? So we have to look at this one, look at that one, and if there's more, keep looking all the way down, right? If we start here, we have to look at this one, and keep looking all the way down. Because when we're in a case like this, let's say this one, the one that engulfs, we can't only merge 2 of them. We have to merge every one that it's engulfed by, right? So that's something to think about. So let's just walk through a decision-making process that we're going to have if we write the code for it. So we at least need to iterate through the existing intervals, and we at least need to know what the new interval values are, right? So we're looking at this one in red and this one in blue. And what in your own mind would you think about if our goal is to populate this results array, right? Remember, we always have some results array. It's up here. What would you think if you were maybe a little computer guy and you have these 2 options, right? Option 1 and option 2. Well, maybe it helps to know if they you know, what's the word for it? Overlap at all, right? So maybe question 1 is like, do they overlap, right? So if they don't overlap, then we know that they're either in this case, right, where they don't overlap this way, or they're in this case where they don't overlap this way, right? So if they don't overlap at all, we know that one of them should go into the results array. And which one should go? Is it the one that has the earlier start or the earlier end? And, kind of doesn't matter, right? If it's the earlier end, well, as long as they don't overlap, whoever's the earlier end is on this side, right? Look at that earlier end. If it's the earlier start, well, that works as well, right? Because as long as they don't overlap, earlier end or earlier start means maybe that one should go first to the results array, right? So let's say this one goes to the results array. We're very happy about that. And maybe I'll make this green so there's at least some coloring difference. Now, our pointer moves, right? So our pointer is going to move. Well, I guess our pointer doesn't move anywhere. So these are two different pointers. This one is going to go across all of the intervals, and this one only points at the existing interval, right? So I guess in this case, where the existing interval is being pushed into results array, we can kind of end that computation, right? So that's the boring case. Let's look at the more interesting case. So let's look at the case where it starts here and it starts here, right? Okay, so does it overlap? It does not overlap. Okay, so if it doesn't overlap, I guess we know that none of this doesn't overlap with any other item in the intervals list or array. So we know that we can safely put this one into the results array, right? And then we iterate the star goes to the next one. Does this one overlap? Does not overlap. We know that we can safely put this one in, right? Because we know this red bar is the only one that can overlap. We get to the end of this iteration. We're done. This one's just kind of sitting around. I guess we should pick it up, clean it up, put that into the results array, and that's how we would do it. Okay, so those are the easy cases. Let's get to the harder case. Let's get to the case right here where the star is pointing to this new interval, and we start at this interval right here. Now what's going on? Well, now it overlaps. Okay, so if it overlaps, what do we do? So we could merge them, but we don't only want to merge with this one, right? We also want to merge with this one because this is in the engulfing case. We want to merge this and this. But I guess if we think about it, we can try to do it one at a time. Right? We first merge this one. If needed, we would merge this one. If needed, we merge a new one. If needed, we merge a new one. And this one's not going to be merged because it's not in there. If needed, we merge that one. And I guess we can just think about it as, one by one, we'll merge it as we iterate this star down in this for loop. Okay, so that works for me. I'll just delete these. We don't really need all these. So we merge this one. And is this added to the results array? It is not, right? Because there's still the possibility it can continue to be merged. So what happens is we merged these two. So I'm going to go ahead and make that red. Don't need to mark it. Make that red, right? These are now merged. Star moves over. This one. Does it overlap? Does overlap. Since it overlaps, we merge it. Perfectly fine. I should have kept one of these. Okay, I'm going to keep one of these and put it out here. Okay, so we merge it, continue the iteration. We're over here on this one. And should we merge this one? Well, it's not overlapping. And the rule that we have when it's not overlapping is actually the same if you look very closely. It's the same as this one, right? When we had these. So when we had these, the thing that was merged first was the target new interval. But then we can also end because once we merge the new interval, we can take the rest of the list, no matter how long the list is, and we could, basically return out of the function. So at this case, when we're at this case where the new interval is before this existing interval and it's not overlapping, that means we have fully merged the new interval. And then the rest of the list, this could be much longer. This could be merged as well. And that pretty much handles, I could delete this line. This handles the case where it doesn't engulf, right? As long as we're doing it one by one, we're just going to iterate our little star here, our for loop, across the existing intervals and merge when needed. And when we don't need a merge, we kind of exit out. And these are the cases. And I could try to write some code here. Let's think through what the code would look like, right? So let's function solution for, let's say, start and end. And the intervals, we have a new start as well, right? And we have a new end. And that's from, that's from target, or that's from new intervals. And what do we do? What are we trying to do? Well, we want to check if it's overlapping, right? So is overlap, question mark. We want to see if it overlaps. We want to see if it doesn't overlap, right? So I'm going to go ahead and put if here, if overlap, else, right? So if it's not overlapping, it's these two cases, right? It's this case and it's this case, right? So let's, which one's easier to code? I guess they're both equally easy. So how do we check if the new interval is before the one that we're iterating over? Well, just like we said before, we can check either the start or the end. So if overlap, if the new is before existing, right? Then for the results array, we can push, or it's Python, so it's append. What is it appending? The new, right? Append the new, right? So this red one goes into the results array, and then we can actually just append the rest of the list, right? So append the rest of the list into the results array, right? So results push, remaining list, right? Starting from new, right? And then I guess we could return out of here, actually. Okay, so if the new is before the existing. What if the new is after the existing, right? So what if the new is this one right here, after the existing? Well, then we can push this one to results, the existing one. And I guess we just have to continue, right? Because there might be a next one that does overlap. So we can push this existing one, and we move the star from here to here, and then we just continue. So, else if put a comment here, if the existing is before the new, then results append existing, and then we just continue. We continue the iteration that we're doing, right? Awesome. And what about this case where we have to merge, right? So let's do the merge case, right? I realized I've done this backwards, right? So this is if it doesn't overlap. So I'm going to go ahead and say if not overlap. Then this is this, and then here else. If overlap, we do something else. So if it overlaps, we're trying to do a merge, right? So the merge would be how do we merge? Let's take any two of these and merge them, right? So let's bring this back to blue. How do we merge these two right here? Well, these are the extremities of the interval, right? The start and the end. And the new start and the new end should be the smallest one of these, right? The smallest one of these starts and the largest one of these, extremities, right? So I'll go ahead and say we're going to merge, right? If it overlaps, we're going to merge. And the new start equals the min of new start and start. Right, this right here, this picture right here. And the new end equals the max of the new end and the existing end. Okay, so that's going to take care of this merging, right? So these will then merge. If we walk through the code, these will then merge after that code. And then as we iterate, it will merge with this as well. And as we get to here, does our code handle this? Does our code handle this case? Well, our code needs to say it does not overlap. So if it doesn't overlap, in this case, we're going to end up right here, right? In this case, it does not overlap. I'm going to end up right here, right? In this case, or the same case, right? This type of non-overlapping where the new is before the existing. And then in this case, this is the case where it is overlapping, but, or sorry, it's non-overlapping. Go ahead and delete that. But it's right here. It is where the existing occurs before the new. And then in this else, we're merging, and that's any one of these cases, right? Or this case even, where we're going to merge them. Okay, so I hope this kind of made sense. I'll write some code because it's more legible than my handwriting. I understand that. So let's just basically write what we have here, right? So we need the new start and the new end, and we're just going to take it out of this new interval list here. We're going to iterate through the intervals, right? So we're going to get a start, we're going to get an end in intervals. And because these are a list of two items, we can basically treat them as a tuple, and this will unpack them for us, right? This will be the start and the end of the existing interval. Okay, so if they don't overlap, we're going to do something, right? If they do overlap, we're going to merge, right? And then we're going to check if the new occurs before existing, right? Else the existing occurs before the new, right? We also want some results array, and that's going to be some array like this, right? So if they don't overlap, how do we know if they don't overlap? Well, let's think about it. Let's look at this diagram. How do we know if they don't overlap at all? So if the new one, right, both the start and the end are smaller than this start right here, then we know that it not only does it not overlap, it's on that other side. It's this case right here. So let me just write the code. So if the new end is smaller than the start, right? That means there's some gap right here. There's some gap right here. It could be large, it could be small. There's some gap right here, right? Then it can't possibly overlap, right? And it doesn't possibly overlap for this case, actually. It doesn't overlap for the new so we can write our code that's here, and our code is going to be, what we had here, which is if the new is before, then results append the new. How do you append stuff? You want to append a list, right? So you want to append the new start and the new end, and then results plus equals the remaining list from new. So how do we do that? How do we actually get the remaining list from new? We're iterating over this with a for in, so we don't actually have access to the indices. So I guess what we could do is set some flag, and that would come back here. But I guess there's no issue in us getting the indices, right? For this in range 0 to the length of intervals, right? Start and end at equal intervals at I, and I guess in this case we actually have the same iteration, but we get the indice, right? So here we can say remaining list from new would be the existing intervals list, but we want to slice it, and we want to take this from, I believe it's I onward, and we don't need to put this here, and then we return. I guess we can actually just return results plus this, and that would be the final answer, right? Accumulating results, and then once you get that case, that's this case right here, where I should have made this red. Once you get this case right here, this is missing something. Once you get this case, then we can just add the rest of the list, right? So I guess we don't need this if overlap thing. So this is no overlap. Let's redesign this a little bit. And then else, or elif, we also want no overlap if existing is before new, right? So existing before new is this case right here. All right, blue is existing, red is a new one. There's no overlap here. So if this it's existing before new, how do we test for this case? Well, that means that the end, which is this one right here, right? This point right here, the end is smaller than the new start, right? Which implies that there's a gap here. So imagine that this is an 8, then this is not an 8. It cannot be an 8. I guess it could be a 7. Is 7 a gap? Yes, 7 would be a gap. See, look. 6, 7 here is an interval, and then 8, 10 is an interval. So 7 and 8 still have a gap, right? So here's a perfect example. I can't believe I got that coincidence. So 7 and 8, if that start is larger than that, that end that it's being compared to, then we know that the new end, right? We don't have to check this one. We don't have to check new end is also larger than the end, because the start is always going to be, to the left of that. So if it's that, then what do? Let's go back down the arrows. This arrow is pointing down to here, existing before new, then results append. Results append is existing, right? And the existing is the start and the end here. All right. So otherwise, there's an overlap. So what do we do with an overlap? We're going to merge them. And let's just overwrite the new start. The new start is going to be the min of the new start and the existing start. And the new end is going to be the min of the new end and the existing end. Okay. So we've merged them, merged them, merged them, merged them. Now, let's think about what we're going to do in this case with the new start at the end of this process. So the problem I have here, so let's just use this one as an example. And I'm going to use what's a color I haven't used yet? This cream color. It looks too much like that one. So let's think about this case. Right, let's think about this case. And maybe I'll just redraw it. So blue, blue, red, right? So, and maybe this red was merged with this blue, right? And this became one bigger red. And now this red is one big piece. And, this blue is already in the results array. That's already in the results array. And this is left over, right? So now we're at this case. We've done the merge. We're actually done iterating through the intervals, right? So here in the code, oh, sorry, I'm not showing it. Okay, I'm going to do that one more time, just so it's super clear what's going on. So imagine we're in the case where we have an interval, and a new interval, right? And in our little, star situation, we've looked at that. We push that into the results array. We go to the next one. We see that they overlap. We do the merge, right? So now they've merged into a single one. And this one is already in the results array. And this one is now merged, right? So now we're on line 23. We've done the merge, but we haven't used it at all, right? So at the end of this for loop, we actually probably need to push this into results, right? We want this one to go into results as well at the end of the iteration. Now, question that I have is, what about the situation where, let's say there's only two of them and they completely don't overlap? What happens in this case? Does our code handle this case? Well, on the first one, right, we'll hit line 16, where the end is smaller, and we've appended this to the results. And we've never needed to merge. We get to the end, and the results now get added. Okay, yeah, it looks like it handles that as well. Okay, so, and then we return results. So let's take a look at our diagram, make sure that we have everything that we want it to have. I understand diagram's a little messy now, but I definitely should have made a duplicate of this diagram, but these are really the only cases, right? So this is case one. Case one is this, right? You have some interval that's new and some set of intervals that exist, and this is completely before it, right? In that case, we do this, right? We return results plus the rest of the intervals. You even have a case where you have new interval in between, and that as well, right? And that's handled by our code, right? So here, this one goes to results. All of these goes to results, gets returned. Here, these individually go to results. Then this goes to results, and all these get returned, right? Perfect case. The other case where we have some and it's on the outside, well, these individually go to results, and then this goes to results as well. That case is handled. And then we have a case where, you know, there has to be some merging. Well, for every one of these that need to be merged, right? Sorry, if it doesn't need to be merged, it goes to results. If it does need to be merged, instead of going to results, it becomes red. This becomes red, right? We do the iteration. This also becomes red. We do the iteration again. It turns out this is the case where, we go ahead and make that gray now. Or go ahead and delete these. This is the case that is exactly the same case as this one, right? This and this case. It's the exact same case. So we return this to results. We take the rest of the list and return that out to results as well. So we've covered all our cases. Let's run this and see if we're missing any Python specific code. Hopefully we're not missing any of the logic. And we're probably forgetting to return something. So this is a bug. We take min twice, right? We're doing the merge. We're taking min twice. Hopefully it's obvious enough why that is not desired. But I can draw a diagram. If you leave a comment, I'll draw a diagram. All right, so we're taking the max, and in this case, we are, finding that 3, 5 is an interval that overlaps. So we merge together with 3, 5. Finding that 6, 7 is something that overlaps. We merge together with 6, 7. Because this has an 8, we're finding that 8, 10 needs to be merged. So these are all merged together with our new interval, right? So at the end, we have 3 separate intervals. This 1, 2, the newly merged interval, and the 12, 6, right? And you could just kind of see that this example would be an example of this. It would be not needing to be merged. And then this red one starts somewhere here, goes all the way here, right? So, if you think about our pointer situation, this one gets pushed to results. This one gets merged. This one gets merged. This one gets merged. This one is non-overlapping, so this one gets pushed to results, and the rest of the list are returned to results. All right, this has been a very long video. I'm really thinking through this as I'm speaking, so hopefully that helps you also think through it while you're speaking. If you want, you can try to solve this with me at the same time, and hopefully what I'm saying isn't too confusing for you. But thank you so much for watching. I hope you learned something, and this would be useful for your own interview practice. All right, see you next time.